Yes, dear students, in this lecture we are going to start with what means mechanical properties of solids. Mechanical properties of not solids, solids already we discussed, right? Mechanical properties of fluids we'll discuss. Fluids. So mechanical properties of fluids which we are going to discuss here. In that first, what we need to means what is meant by density. Density basically what we can write it. Density can be written as what sir means mass by volume. So how can you write SI units? SI units can be written as kg per meter cube, sir. How can you write CGS unit? Gram per centimeter cube, sir. That can be written as what sometimes gram per cc. Cc stands for centimeter cube. Also, we can write it here. So density of water is how much basically? Density of water is 10 power 3 kg per meter cube or 1 gram per cc, 1 gram per centimeter cube, which we can mention here. Fine. Density of mercury also required. You have to remember sometimes. Density of mercury is how much? 13.6 gram per cc. You can convert this value also in terms of SI units also, kg per meter cube also. And density of blood also you have to remember sometimes. Density of blood is how much means 1.06 gram per cc, which we need to remember. Fine. Now, density expressed in gram per cc is also can be called as what means relative density or specific density. You will get this terminology in numericals, Nana. The density expressed in gram per cc means in CG units is called as relative density or specific density of the water. They'll mention in the question. That is also CGS unit like that. So specific density. So if you want to write dimensional formula is not a difficult task for this fellow. Mass stands for m power 1 divided by L by 3. Na? That's nothing but L power minus 3, which we can write dimensional formula for this fellow. So now to convert grams per cc to kg, what we need to do? We need to multiply what 10 by 10 power 3 na here. So 1 will become 10 power 3 in SI units. So to convert gram per cc to kg per meter cube, multiply by 10 power 3. We should multiply by 10 power 3. Fine. So let me discuss numericals. So what we're having means two liquids we're having. Nana. In these two liquids, first liquid density is ρ1, mass is m1, volume is v1. Second liquid density is ρ2, mass is m1, volume is v2, which we're having here. This first I'm considering case 1. Nana. In this case 1, what I'm commenting means if volume is same. If volume is same means what will happen means V1 value should be equal to V2. There should be some value V only, let me take. And mass is what will happen? Mass is not changing. M1, M2. And density is how much? ρ1 and ρ2. Now I want to give relation between net density. Final density I want to give here. See, if you observe here carefully, what is density formula? Density equal to total mass upon total volume. So rho can be written as what means m1 plus m2 divided by v1 plus v2. But v1, v2 value both are same in this case. V plus v, which we can write it here. You know that density can be written as what, sir? Mass by volume. Mass can be written as what? Rho into v. So m1 can be written as what here? Rho1 into v. M2 can be written as what? Rho2 into v. Why I am not writing v1, v2? Because volume is same in this question. v1, v2 value both are equal. So just substitute that value. Rho equal to, in the place of m1, ρ1v, in the place of m2, ρ2v, divided by v plus v is how much? 2v, which we are having here. Now, if you observe carefully here, so what we can take common here? Rho equal to ρ1 plus ρ2 will get into v divided by 2v. vv will get cancelled. Therefore, rho equal to what will get it means? ρ1 plus ρ2 divided by 2. So, if you mix the two liquids here, whose volume is equal and masses and densities are not equal, so you will get resultant density will get like rho equal to ρ1 plus ρ2 divided by 2, which will get it here. For example, let me choose second case here, Nana. Case 2. In case 2, what we are choosing here means if masses are equal. If masses are equal. If masses are equal means what we can write it here? M1 value equal to M2, that equal to what we can write? M, we can write it here. So again, let me write same formula here. What is the basic density formula? Density can be written as what, Nana? Total mass upon total volume. Masses are equal, na? M plus M divided by what we are having? V1 plus V2, Nana. So density equal to, you know, that mass by volume. Volume can be written as mass upon density. I'm switching this both. I'm sending this fellow here and send this fellow here. Therefore, volume equal to volume 1 equal to M by rho 1 I'm writing. Volume 2 equal to M by rho 2 I'm writing. Why I'm writing, you might got here. M1 and M2 is both are same, na, here. M1 equal to M2 equal to M, na. So substitute here. So if you substitute rho equal to what we'll get it here means M plus M will be 2M divided by M by rho 1 plus M by rho 2. So what we can do here, you can take M common, Nana. So rho equal to what we can write means 2M. M if you take common, no, 1 by rho 1 plus 1 by rho 2. So MM will get cancelled. So if I send these two here, no, I'm sending these two here, I'm reciprocating this equation. Understand carefully. Send this two here, it will get by 2. I'm reciprocating this equation. 2 by rho equal to 1 by rho 1 plus 1 by rho 2, which will get it here. This is for what? 2 liquids. If you want to write for 3 liquids, no, same formula you can apply here. 3 by rho equal to 1 by rho 1 plus 1 by rho 2 plus 1 by rho 3, which we can write it here. Only for 2 liquids, if you want to write equivalent formula, no, rho equal to, if I take LCM here, 2 rho 1 rho 2 divided by rho 1 plus rho 2, which will get it here. This is for only for 2 liquids, which we can take here. Here, if you want to write for 3 liquids, what will get it? Rho equal to rho 1 plus rho 2 plus rho 3 divided by 3. If you want to extend for anything also, you can write. For anything, so can you extend rho equal to rho 1 plus rho 2 plus rho 3 and so on up to rho n divided by what will get, Nana? N, which we can get it here. When volumes are equal, we'll get this equation. When masses are equal, densities combination will get this equation, which we have to understand carefully. Yes, fine. Yes. Next, what we are going to discuss means here, we are going to discuss about the what? Variation of pressure with depth. Variation of pressure with depth. So you have to understand carefully this concept, because this concept they can ask you for boards also. Let me take a container here. And this container, some liquid is filled, Nana. Here some liquid is filled here. Now, if you observe here, no, what is the height of the container they given means h they given. Since it is open with the atmosphere, no, let me take atmospheric pressure is how much P naught here. Total mass of the body or this liquid is assumed to be considered at a point B here. How much is that weight will acting means weight is nothing but what we can write generally mg we can write here. Acting down here. And what is the density of the liquid means density of the liquid is taken to be rho. Density which we taken as rho here. Now, if you want to discuss here, no, how can you discuss pressure of the liquid means pressure of the liquid equal to what we can write means force upon area, which we can write it. Pressure is nothing but force upon area, na? So pressure of the liquid can be written as what means here force is nothing but what weight of the liquid here, which we have to take. So what we can write here weight of liquid over area. So pressure equal to what we can write it here, Nana? Mg upon A, because mg is nothing but weight, na? That equal to, so in the plus of m, what I'm going to substitute means density terminology. Mass is nothing but density upon volume. Sorry. 1 second. Okay. So density equal to what we know? Mass upon volume. Mass equal to density into volume, we can write it. So what we can write here? Density into volume times G divided by area, we can write it. So pressure equal to density into G divided by A into that volume I want to write. H is nothing but height, A is nothing but area. Na? Therefore, volume I can write like this. Na? So what we'll write means here, volume can be written as area into H. Na? So A into H, area will get cancelled. Pressure equal to what will get it? Rho GH, which will get it here. So this is nothing but pressure, but not complete pressure. So total pressure, if you want to calculate here, no, what will get it means? P total can be written as what means? P liquid plus P atmospheric. So P total can be written as what means? P liquid is how much here? Rho GH, which we got it here. Rho GH plus atmospheric pressure, what we got it here? We given here how much? Observe here. P naught, which we given here. P naught. So plus P naught. This is nothing but final pressure, total pressure formula. And here, what is P naught here means? P naught is nothing but what here? Atmospheric pressure. P naught equal to what we can write here? Atmospheric pressure. Atmospheric pressure. So how much is that value which we are having according to NCERT? 101.3 into 10 raised to 3 pascals, which will get it. So if you make it approximation, P naught equal to 1.013 into 10 raised to 5 pascals. So it's very small value, 1.013 means. So we can take order of 10 raised to 5 while solving the numericals here. So final formula, what we got it here means P equal to rho GH plus P naught, we got it now here. So where H is nothing but what means? Depth from the surface, Nana. Depth from the surface. Now, if you want to check now, if I take this P naught here, no, P total minus P naught can be written as what means here? Rho GH. This is called what means? Gauge pressure, which we can call it as gauge pressure. The difference between total pressure minus atmospheric pressure is nothing but what, Nana? Gauge pressure, which we can name here. This is the important formula here. So force upon area, weight upon liquid, weight is mg. This substitute this value, area will get cancelled, rho GH. Total can be written as P liquid plus P ATM. What is atmospheric pressure means? 101 into 10 raised to 3 pascals. For solving numericals, we can consider as 10 raised to 5. So you have to remember standard formula this thing. So with the depth, what will happen? Your pressure means increases, Nana. Rho GH. Now, if H value is increasing, pressure will be increasing. So with the depth, pressure will be increasing. Therefore, P total minus P naught equals to rho GH. That can be called as what? Gauge pressure, which we can call it as here. Yes, Nana. Now what we need to check means we need to check pressure on horizontal line. Pressure on horizontal line of the liquid. Means let me take one container here. We're having a container. In this container, we filled up to here liquid, some liquid we filled here. Now, so I want to find at B and at C, I want to calculate pressure. These both are parallel, no? So on horizontal line, I want to calculate. Let me take one cylinder here, symmetry. So on this cylinder, what will happen means, from here to here height, let me take as H1. So this total height of the liquid, let me take as H. Or let me take this point is A. I want to relate point A, point B, point C. Potentials I want to relate. So about this fellow, what is acting force here? F. About this point, force is acting how much here? F. So that is force is due to what, Nana? Force due to other particles acting on this particle. Force due to other particles. So these both are horizontal line. So F1 should be equal to basically what means F1 should be equal to F2. Pressure equal to what we written? F upon area, sir. F can be written as P into area. So what we can write here means we can write like this. So what we can write? P1A is equal to P2A because cylinder I'm choosing, both areas same. So this fellow equal means 1 can be taken as B, 2 can be taken as C. Therefore, PB equal to PC, which we can write it here. Then what about the PA? PB equal to PC, that equal to how much? Rho G H1, Nana, at height of H1, which is in here. Okay, at height of H1, you choose like this. Next, PA, if you want to check, PA equal to what we can write here? PA equal to P naught plus rho G H, we can write it here. H is very large with compared to the H1. So what we can tell, pressure at A is greater. With the depth, pressure will be greater, na? So how can you relate these things? Means PB should be equal to PC, sir. That should be what? Less than PA. We can write it here. So this is nothing but relation. So with the depth, pressure will be increasing, and on horizontal line pressure will be equal, which is we have to remember. This is at when acceleration is 0, means object is at rest. So next case, what I would like to discuss here means pressure on the horizontal line if the liquid is accelerating in a horizontal direction. What we need to discuss? Case 3, case 2 we already discussed. This is case 2, you take it. Case 2. In case 3, what I want to discuss means pressure on the horizontal line of the liquid is moving with acceleration A along the horizontal direction. Along horizontal direction here. See, let me take a container here first. In this container, some liquid is here. Now we are moving container in this direction with acceleration A. If you're moving container with an acceleration A, generally what will happen here? If this is point B, if this is point C, I need to relate the potentials. Sorry, I need to relate the pressure between these 2 points. So if you want to relate the pressures, no. So generally, if liquid is moving forward direction, no, backward what will come here? Pseudo force will come. That is nothing but MA, which we learned in Newton's laws of motion. Downward what will come? Mg. If vehicle is moving forward, no, and you how pseudo force will act backward direction, you feel backward direction similar way. MA, Mg. That's why here pressure will become more with compared to this fellow. So resultant diagram, if you observe, no, if vehicle is going like this or container is moving in this direction, what will happen means you can able to see that liquid shape like this, you'll get it here. So what we can assume, this side is pressure is more with compared to this side, we can tell now here. So how much is that pressure value means I can give relation here. PB minus PC, the difference value should be equal to how much means rho AL, which we know here. For example, you want to relate 2 more points like this, vertical points, which we already learned. Here I'm having liquid here. This will let me take as A. This will let me take as B. So pressure at B can be written as what, Anna? Atmospheric pressure PA plus rho GH, which we can write it here. So PB minus PA equal to what we can write it? Rho GH, which we can write it here. If this depth is how much? Height if we taken here. See, let me see one question here, how they ask for NEET and which is there in NCERT also, the same one. They given one question like this, Anna. They given one container like this. They given one container like this, closed container. In this container, what they did means they filled some liquid here. And they given here 3 points, 3 reference points. This is point C, and this is point A, and this is point B. From point C to point B, height is how much they given means H. From point C to point A, length is how much they given means L they given here. And they are telling this container is moving in this direction with acceleration A. Then calculate PB minus PA is the question here. If you observe carefully, this question is there in NCERT concept, as well as they asked in NEET 17, and a similar question, not exact one. I've just changed similar question. See, if you observe here, if you want to answer for this fellow, since this fellow is accelerating in this direction, you can tell that PC minus PA, this fellow is greater. So what I can tell means PC minus PA equal to rho GH, rho GL, which we can write it here, length. If you observe these two, with the depth, this fellow is higher, no? PB minus PC equal to what we can write? Rho GH. PB minus PC equal to what we can write? Rho GH, which we can write it here. Now what I'm going to do means, you just add these two. PC minus PC will get cancelled. PB minus PA. PB minus PA equal to what will get, Nana? Rho GH plus rho GL. So if you want, no, you can take rho G also common. So what will get it? PB minus PA equal to what will get it here? Rho G, if you take common, no, H plus L will get it. Sorry. In this direction, acceleration here we are having, no, this is rho A L, Nana. We made a mistake here. Observe carefully. No G here. Acceleration will come into picture here. rho A, rho A. Means we cannot take rho G directly common here. So how much remains means here? So PB minus PA equal to rho only we can take common. We can write like GH plus AL, we can write it. Acceleration of the body. If they ask you numerical values, acceleration of the body also they'll give you in the question here. See, now we're going to discuss NCERT concept and question. So U-shaped tube problems. U-tube problems. In that question, what they given means they given one tube like this, Nana. Like this shaped tube, they given one tube like this. They given one tube like this. In this, they're filling some liquids here. So how they fill means from here to here, one liquid they fill here. From here to here, one liquid they fill here. Next, up to here, they fill another liquid. Some other liquid they fill, Nana. Then one more liquid they fill here, from here to here. From here to here, they fill one more liquid here. In the question, what they given means here, this liquid is nothing but CCl4 they given here. This liquid is nothing but mercury they given here. This liquid is nothing but water they given here. And this height of this liquid is they given in the question they mentioned is height of CCl4. They given like 30 centimeters they given here. What we need to calculate means we need to calculate in the question height of the water we need to calculate. Question is, if you observe carefully here, about this point, let me choose 2 points. Let me take this is like A, this is like B. Pressure on horizontal line, I told you same thing. Na? If I check here now about this point, pressure should not be equal, though it is horizontal line. Draw, it will be horizontal line, right? But pressure is not equal. Why? Because if you observe here, no, about this point, density is not same, Nana. Because different liquids, no, this is CCl4, this is what? Boundary of this H21 mercury. That's why it is not equal. Now what we are going to do means we are going to do check here about this point. Let me take this is like B dash. Let me take this is like A dash, Nana. This is also horizontal line. Now if you check pressure in here, no, here pressure should be equal. Because this is nothing but mercury. Here also what is there here? Mercury is there. This is H means remaining will be how much, Nana, here? 30 minus H, we can write it. 30 minus H. Okay. Now if you observe here, no, about this point pressure if you want to write, no, due to this liquid plus due to this liquid. About this point pressure you want to write, no, due to this liquid plus due to this liquid, you can write it here. So fine. Since it is open with the atmosphere, no, here. So what we can write here? Here what will be there, Nana, here? Atmospheric P0. Here atmospheric pressure P0. So what I can tell here clearly means here pressure at A should be equal to A dash should be equal to pressure at B dash. We can write it. Understand carefully. This liquid same and horizontal line. That's why pressure is equal. I'm writing here. Pressure at A dash should be equal to pressure at B dash. Pressure at A dash due to two liquids. P0 plus rho GH for due to what, Nana? Water plus rho GH due to this mercury. So I'm writing here P0 plus rho GH. Rho value is nothing but 1 na, for water into G into H plus due to this also we have to write pressure. That's nothing but for mercury 13.6 into G into H is how much, Nana? 30 minus H we got it, na? 30 minus H. That equal to what we can write it? This is only a single thing. P0 plus rho GH. P0 plus rho is how much, Nana? Rho GH. CCl4 density how much they given? They mentioned in the question right here. Rho equal to 1.6 gram per cc. Okay. So density is 1.6 into G is G only. Into height is how much? 30 centimeters they given. If you observe here, no, plus P0, if it comes this side also, P0 will get cancelled. In these three terms, if you observe, G we can take common here. We can cancel with this G. This G, this G, this G will get cancelled here. So what remains here? H plus 13.6 into 30. 13.6 into 30, if you multiply now, you'll get like 408 minus 13.6 H is equal to what we'll get now? 1.6 into 3. 16 3 is 48. Na? So what you get it here? 48, you got it here. Therefore, if I check this value, so if I send this to this side, so 408 minus what will you get now? 48 equal to 12.6 H. Why? Because 13.6 H plus H na here. This is minus, this is plus. So this answer, how much will get it? Means here 360. 360 equal to what will get it? 12.6 H will get it here. So H equal to what will get na? 360 divided by 12.6 you'll get it here. So if I cancel these both now, we get H value like thing, but 28.6 centimeters, which we got it here, which you have to understand. Pressure at these 2 points not equal because densities are equal. Pressure at these 2 points are equal because density is same here. So let me show you one more question here, a little typical question, which is they asked in NEET 17. So there is no difference between NEET and JEE. So same standard question only they will ask you. Okay. So let me take YouTube, one more YouTube. We're having one YouTube nana like this. U-shaped tube. YouTube ka matlab. They given on YouTube like this. In this, they given how many liquids, means 2 liquids they fill here. So they're filling 1 liquid here. Up to here, they're filling 1 liquid. From here, they fill 1 liquid here. And from here to another liquid they fill here. Up to where? Up to here, Nana. They fill like this. Try to understand carefully. So in the question, what they tell means, they're telling this height they given here. How much is that height they given in the question means? Height of the liquid is they given like 140 millimeters they given here. 140 millimeters. And this is they're telling some oil, Lana. And here they told like this gap is how much, means the gas gap they given in the question 10 millimeters they given here. In the question only this they will mention here. And here what is this liquid means? This is nothing but Pinica Dandapani water they given here. Now if you want, what we need to calculate means we need to calculate density of the oil, we need to calculate rho of the oil, we need to calculate. There is a question. Rho of the oil. See if you observe carefully here, no? What we can do means this total is 140 nana. This is 10 means this should be how much? It's very clear, sir. 140 minus 10 is nothing but 130. Since it is open with the atmosphere, this pressure is how much? P0. This pressure also how much? P0. If you observe, pressure at these 2 points is not equal. Though these are horizontal line, pressure is not equal. This is oil, this is water. That's why I'm going to check pressure about this point, pressure about this point. Both are horizontal lines. Na? So let me take this like point A. Let me take this like point B. So this is nothing but horizontal line if you observe. Horizontal line, and here also water is there. So that's why I can tell that pressure at A should be equal to what? Na? Pressure at B. Pressure at A should be equal to pressure at B. Pressure at A due to the side plus atmospheric pressure. So P0 plus rho GH. Rho into G is how much? G only let me take. Into H is nothing but how much we can take? 140 millimeters. Take like millimeter only. Is equal to pressure at this point we can write like P0 plus due to this height, Nana, due to 130. So P0 plus density of water is how much? Density of water is 1, 1 into that's nothing but 10 power 3 also you can substitute if you want substituting SN. It's 10 power 3. G is G only. H is nothing but how much you are writing? 130. So this P0, if I take other side, it will become 0. And this G and this G also will get cancelled. Rho equal to what we can write? It means 130 into 10 power 3 divided by what we are having here? 140 we are having. This 0 will get cancelled. 13 by 4, Nana. 13 by 4 is nothing but what we get? It means rho equal to will get like 0.13 928 into 10 raised to 3. So if you want to convert into grams per cc, kg per meter cube, no, 10 power 3. So just send power inside. So rho equal to what will get it? 928 kg per meter cube, which we are having. So this is the answer. Option they given it up SI units, that's why I took SI units. But if you want to convert grams per cc, what you have to do, you just have to divide by 1000 here. P equal to PB. Pressure at point A should be equal to what? Due to this height plus atmospheric pressure, P naught plus rho GH. Rho into G into H is how much? Aisle height is 140. That's what I mentioned here. Equal to P naught plus rho GH nana. Rho is how much? Density of the water is how much? We know that like 10 power 3 kg per meter cube. Into G is G only. Height is height of the liquid column from here to here is how much? 130 nana. So P naught plus P naught will get cancelled because this is P naught. Now if it comes this side, no, minus P naught it will become. That's why cancel. Rho G into 140 equal to 10 power 3 into G into 130. G also will get cancelled. So rho into 140 equal to what will get? 10 power 3 into 130. So 130. If I send this fellow here, no, 130 divided by 140, 1010 will get cancelled. So how many times will go means 0.92 times it will go. So 0.928 into 10 raised to 3. So if I send power inside, no, if I multiply by 1000, no, 928 kg per meter cube, which will get it. Same questions as it is, they will ask you in JEE, CET, and NEET also. So similar questions only they'll ask you. This is the two types of questions where they can ask you. Once they can ask you density, once they can ask you height. So very important questions which for competitive, and CBSE boards also sometimes they can ask you. So you have to revise these all things once again carefully. This is for today's class. Thank you, dears.